Let's now take a look at another example. Here I'm trying to calculate all the indices at which this object appears in the list. So the code is similar, except my output is going to be a list of integers. Again, we have an accumulator pattern, but this time our answer is a list, and we are appending certain values of I, certain indices to this list. How does the code work? Well, we initialize I to 0. We check if I is less than the length of the list. As long as it is, while I is less than the length of the list, we check if the ith object in the list is the object that we're searching for. If so, we append this index I to the list, and then very importantly, we increase the value of I whether or not this if condition was true. And then we would check the next value of I and the next value of I, and we would keep doing this as long as I is less than the length of this given list. And when it is no longer true, when this condition is false, we would come out and return whatever result we have accumulated. Again, this code is very easy to rewrite using a for loop. In this code, I don't use the syntax for item in data. Why? Because in the body of the for loop, I actually need the value of I. So I say for I in range len data. We have seen this syntax before. We know it produces the values I equal to 0, 1, 2, all the way up to 1 less than the length of the given list. So for all those values, once again, I will be automatically increased for us. We don't have to do that manually. We check if the ith object in the list is what we're looking for, and if it is, we append it to the resulting list. Now, you can actually make this code even simpler. Many people write code like this, but you can make it slightly more efficient by writing it this way. So for any sequence, we can call the enumerate function on that sequence, and this will actually produce pairs of items. The first item in that pair is the index, and then the second is the actual item at that index. So we can write this kind of syntax for I, item in whatever is being enumerated. So each tuple that comes out of this enumeration will be unpacked into its I component, which is the index, and its item component, which is the actual value at that index. And then we can write code similar to what we saw before. If that item is the object, then we can append the index to the resulting list. And in fact, if you asked your Gen AI to write this code for you, it would use code that is even more efficient. It would use a list comprehension. If you write return, and it would immediately recognize that it can write this code using this syntax. So it will return all the values I. And where did I come from? Well, we looked at all I, item in enumerative data, and we only kept those values of I where item was the object. As we have said before, list comprehensions can be a little bit tricky to read. It takes time, but I'm sure at some point you will get comfortable with at least reading list comprehensions, even if you choose not to write them yourself.